Okay, so good morning, good afternoon, good evening to everybody. As Stefan said, we have people from all over the world, so it's always a good thing. And so here, indeed, my topic today is to introduce what we have done with ChatGPT in BayesiaLab. So the title is ChatGPT as a subject matter assistant, but we're going to see that we have also another feature for that. So let me switch here. So just here, just when I was preparing this presentation, I thought about my very first prompt when I used ChatGPT last year, and it was very surprising, as you can see, a question like, what is a Bayesian network? So it was still a very classical Google-style search, right? And when I received this answer, I was really impressed because first, it's very nicely written. And I thought, wow, I don't know how many articles we have written about Bayesian networks, and you are always, trying to find a way to describe what is a Bayesian network, and you did that 20 times, and you always try not to repeat yourself. And this one was kind of original. It's not just an excerpt from Wikipedia or on another website. So it's really something that had been synthesized. So I was really impressed with that. Then I followed this chat with another prompt. What is the best Bayesian network software? It's like being auto-focused here. And then I have this answer where we have the list of software, including BayesiaLab, again, Netica, G9, and so on and so forth. And here it was like absolutely not again as Google, because it seems that the information has been digested and summarized. So, and it was kind of giving an advice, right? It was even more impressive than the first answer, right? So, being an AI researcher since more than 30 years now, it was really something amazing. I say, wow, this is like a dream. This is really what we are looking for since so many years. But how does it work? So I know it's not perfect, but still it's super impressive. So, and even though we are searching in the AI field, but mainly obviously about Bayesian networks, well, I was not really, aware of all the recent development in the field of NLPs and generative models. So I started to dig and to investigate here. And then I thought that it's super impressive machinery here with shallow and deep neural networks. You have supervised and supervised learning. You have also reinforcement learning. And I did my PhD using neural networks, reinforcement learning 30 years ago. So it was kind of refreshing. And I was really, really impressed with the machinery behind ChatGPT, right? So something that is probably one of the most important piece in this machinery is based on this article. Attention is all you need from Google in 2017. And then with this now famous figure that illustrates a transformer. So I went there and I really tried to understand all these little pieces, and it's really, really nice, right? So I'm going to talk about in 20 minutes or so about embeddings that you can see here, which are the really starting point of the GPT, if you will, and all these attention mechanism and so on and so forth. So it's really fascinating, right? And then the question was, well, so it's super exciting, but how can we integrate this technology into BayesiaLab? What can we do? How can we leverage this technology in order to help our customers, right? And as you may know, since 3 years, more or less, we are doing brainstorming session every 2 or 3 weeks. And then obviously now the answer was, well, it's probably the idea is to use it to build a kind of subject matter assistant that will help us when we do brainstorming sessions. So it's going to be another expert. So we are working with a team of 5 to 12 or sometimes 20 experts, but then we're going to have another one that we will be able to use in order to ask questions, even though, again, we're pretty sure that the answer are not 100% okay. Well, you always have to check the validity of the answer, but still, this is more or less the same thing with human beings at the end of the day. But here, so we will have some tools that will help us to find what are the dimensions that we are going to be able to use in order to have a good description of the domain under study, right? And the second part of my talk will be about what I call the semantic network. So it's now something slightly different because we are going to use BayesiaLab for building a network that will show the relationship, the correlation, I will say, between semantic items, right? So we are not going to use the quantitative part of Bayesian network, except obviously for learning the dependency between the items, but otherwise we are not going to do inference, if you will, for seeing what is the impact of observing this item. So this is not what we are looking for, but we are going to use that for having a very nice representation of the domain under study. And for that, I'm going to use 3 examples. The first one, I'm going to use the S&P 500, you know, our classical example, the one we have used in our book, and that the one I'm using in all my trainings. Then the second one will be about finding relationship between authors. And here I'm going to use this example to show that we can obviously use these items not only for creating embeddings for name, but enrich these embeddings or these nodes by using comments, right? So we are going to build a kind of PSEM, so probabilistic structural equation model, if you will. And the very last example will be about using the SMA, okay, so the subject matter assistant, for creating or for, finding what are the nodes that we have to use in order to have a large sample of the dimension of the domain. And then same thing, we are going to learn the dimension, the relationship between these dimensions, right? So here I'm going to use 4 videos. I had to do videos because we never know. I don't want to have any timeout in my presentation or, an outage of ChatGPT. Right? So let's start with the first topic, using ChatGPT as a subject matter assistant. So as I said a few minutes ago, since 3 years, we are really, organizing brainstorming session on a regular basis. And so here I have generated this image where you have these experts. So we are brainstorming with them. And last year during the conference, I presented, the new way to use a Delphi approach for dimension elicitation. So this approach allows us to not only to remove all the anchoring biases when we do this dimension elicitation, but also allows to speed up the process of capturing what are the most important dimensions, right? So at the end of the day, so experts are using big key for listing all the dimensions they want to add in the network. And with our facilitator here, we are generating, sticky notes for each expert, and then we are analyzing what are the dimensions that we need to add, and then we create the network, right? So now the idea is to create a target node as always. So here I'm using an example we have of a network we have created a few months ago about economical inequalities, and the idea is to use our new subject matter assistant. So I hope you are not scared with this image. I kind of like it. I don't know, it's because it contains my favorite colors, red and black, but this is an image that has been created with DALL-E. And so this is the representation of my subject matter assistant, and I'm going to ask him the question for you, what are the 5 most important causes that explain economical inequalities? And then I'm receiving the answer from ChatGPT. So here you see education, discrimination, globalization, taxation, and inheritance, right? So this is really how we are going to use it. So let me use a fictitious example here. So, I had lots of different ideas what to illustrate this, and finally I decided to use the wildfire. So because we have more and more wildfire now, and I said, okay, let's try to build a network on this domain, right? So I'm not an expert at all in this field. I don't have any experts. So here I'm just going to start this video with a presentation where I'm going to first remind you how we use a Delphi approach during our brainstorming session, right? So it's a kind of reminder of what I've introduced last year, right? So we create the node, then we are gonna open the interactive B-key session, right? So this allows me to automatically create my 5 experts in this example. So each of these experts will be able to use B-key, so our web solution, to directly, answer the question. So not only now the probabilities associated with the nodes, but also the dimensions that we want to add in our model, right? So I have my node wildfire here. Then we go to the comment field, and this is where I'm going to write the question I'm asking to the expert. So here the question is quite simple. What are the top 3 dimensions that have a causal impact on the wildfire? And then I'm just emphasizing on the fact that they have to use the comment field to create a list of dimensions, right? So this comment is going to be used by B-key in order to generate a question. So now I'm sending this question to B-key, and every expert, so my 5 zones here, are going to receive a question. So here you see what are the top 3 drivers, right? And they're going to use the comment field here to answer. So this first expert say, okay, lightnings, important weather conditions, and fuel accumulation, right? Then in BayesiaLab, I can follow here, and I know that this expert answered this question. So then the second one, it's not then, it's at the same time. So she is answering arson, smoking, and campfire, right? And then she validates the answer, and obviously we are receiving that in BayesiaLab. So let's suppose I have just these 2 experts, these 2 answers. So I'm selecting these 2 answers, and then I click on generate node from comments in order to have this sticky node. So this way, I have the list of the dimensions that have been chosen by my set of experts. So on the right, you can see that this is a real picture of a brainstorming session we did in September. So here just a subset, because we had 25 experts. So we had 25 sticky notes like that. And then the facilitator has to select, what are the dimensions that we are going to finally add to our network, right? So this is how this is working, right? So now we are going to describe how our subject matter system is going to work. So same thing, I have my wildfire node. Then I go to OpenAI, so in Tools, OpenAI, and I'm going to select subject matter system. Here I have a list of, actually right now we have 21 types of requests, right? So traits, characteristic, feature, dimension, causes, drivers, and so on and so forth. Then so I'm going to select one. So I want the causes, and here I have the number of answers. So I want 5 answers. I have this field that I can use to describe the context of the domain, right? So here it's wildfire. Then I'm selecting the input type. So the input types, this is at the end of the day the node here. So am I going to use, for generating my question, my prompt, am I going to use just wildfire, which is the name, or the long name, or the comment, right? So if I'm selecting long name and comment, and if I don't have comments nor long name, so it's going to be name, right? So here, this is at the end of the day just wildfire, right? And then I click on Find. And so the prompt is generated and sent to ChatGPT. And we have the list of answers. So I have my 5 answers. So the first cause is human activity, right? Campfire, cigarettes, fireworks, arson. Then lightning, drought, wind, and climate change, right? And I have my last column here is for deciding if I want to keep or not this variable. So climate change, it's probably important, but it's not a variable anymore, right? It's true, right? So the climate is changing, so it's not a variable. So I'm unchecking this dimension, right? And I have the option to create a class for each of these nodes. So here, the class is wildfire causes, and I have a sticky note to highlight this set of nodes. Now I'm going to ask another question. So what are the main requirements, for example, right? So I select requirement 5 and then find. So prompt is sent, and I have my 5 answers: fuel, oxygen, heat, weather, and topography. And I'm selecting these 3 nodes because I'm going to assume that oxygen is true, heat, we already have it with draft, and weather, same thing, right? So I just add fuel and topography. Then I have another sticky note here. And now I'm going to try to have a more precise description of human activity, right? So I'm going to use my SMA in order to find what are the causes of human activity in the context of wildfire, right? So I sent the prompt, and then I'm receiving here the 5 dimensions, so campfire, cigarette, fireworks, arson, and equipment use, right? So these are the dimensions that will be used for defining the human activity, right? So now I'm gonna just create the structure of the network, right? So this will allow me to remind you how to use ICI. You know, this is something I presented 2 years ago. So this independent causal influence feature. So I'm selecting my targets, it's human activity, and I'm gonna define a noisy OR, right? So the human activity, or at least the ignition due to human activity, will be a noisy OR between these 5 nodes plus a leak. So this is to represent, you know, all the other causes that I did not include in my network here, right? So this feature allows me to automatically create this noisy OR, right? So I do a little bit of formatting here. And now I'm going to add, you know, lightnings. So this is my, I would say, second cause for ignition. So I'm creating here a node ignition that's going to be defined by a noisy OR between human activity and lightning. Right, so first selecting here the target, ignition, select noisy OR, no leak, and then I click on OK. And the thing is, since I have already defined human activity with a noisy OR, I don't need to add any mechanistic node here. So I just connect directly human activity to my OR, right? Then I'm going to create the concept of fire, right? So we have the concept of ignition. Now I'm going to add fire. So I need ignition plus some fuel and some heat, so draft, right? So I create the node fire and use here an AND, so noisy AND. I'm selecting the target, then the AND. I don't need any leak node here, and I'm defining the name prefix. Right, so now I have human activity, ignition, then same thing here. I'm connecting directly ignition to my AND, and then I have then defined my concept of fire. Right? Now I'm gonna add, you know, define the concept of propagation. Right? So I need to use wind and topography. And then I create my node propagation, and it's going to be a noisy OR between these two. So same thing, selecting these nodes, tool, ICI, and OR. A mechanistic local effect, and my prefix P. Right, so this is my propagation. And the final one is to connect wildfire. So the wildfire, it's going to be an AND between these two. And it's not a noisy AND. So I don't need to add a mechanistic local effect. So it's just a pure AND between these two, right? So I've represented wildfire with these three main components: ignition, fire, and propagation, right? So as you can see, we have lots of nodes here that have been created very, very efficiently, right? But it's still here purely qualitative, right? So we need to ask the experts to populate or to define what are the states of these nodes and to define what are the priority distribution, right? So here I'm just gonna show you one example with the campfire effect. So this is a local effect. As you can see, we are generating automatically the causal question. So the expert has to answer what is the independent local causal effect of campfire on human activity, meaning ignition due to human activity in the context of wildfire, if you will. So again, I don't have any knowledge here, so I'm just gonna give a brief example. So if without campfires, no problem. And here I'm just assuming that with campfire, we have 5% of risk to have ignition due to human activity, right? So now the last step will be to make this network nicer, right, and more readable. So I'm going to start by removing, so I'm assuming that all the priority distribution have been defined, right? And I'm going to just remove or hide, if you will, the name of the nodes that are not directly useful for the end user, right? So I'm selecting here the local effects, and then I'm hiding their names. And I'm going to do the same thing with the ICI nodes. So I'm selecting these nodes and I'm hiding their names. Right? Now, since I've created some kind of latent variable, I'm going to highlight them with, the badges. So instead of just using the disk node, I'm using badges. And now I'm also going to select the root nodes plus these latent variables. And I'm going to use DALI for automatically generating icons to have a nicer model, if you will. So here, a request is sent to DALI, and this will generate an icon based on the name of the node or name plus comments. So it takes some time, and here now we have an icon for all the nodes I have selected, right? So sometimes they are not that nice, so it's purely random. So if you run a second time, you're gonna generate another icon. So for example, this one, propagation, I'm not happy with it, so I can just rerun it, and this will generate another icon, right? So I know that propagation, it's not a concept that is not easy to illustrate, but well, anyway. So it's quite surprising, sometimes the quality of the icons that are generated, very useful. And obviously, if I were to really describe the domain here of wildfire, I would have to take into account what are the consequences. So then I would select consequences and then hit find. This allows me to have, as usual, my 5 dimensions, my 5 consequences, destruction, along with a nice description, right? And then, right, so this is creating the nodes. I'm gonna show the sticky nodes and delete these ones. And I'm continuing. Let's suppose now I'm interested in finding what are, for example, the barriers. Same thing. So ChatGPT answer gave me 5 barriers. Let's suppose that I'm not really satisfied with that. So let's say, okay, let's go for preventers instead. So I click on preventers and fine. And here, well, I have education, clearing, equipment, planning, monitoring. Sounds good. So I just do okay. And I have my 5 preventers here, right? So this is just a fictitious example where I show you here how we can quite quickly build a network that is very, very nice, right? And not just nice, but also useful. But here, this example was just without any expert. So you have to imagine the same thing, but with a group of experts where you're going to really use that as an assistant. So another expert in the team, right? So now let's switch to the second topic. So where we are going to talk about semantic networks. So again, this is just about building a qualitative network that will show us the strongest correlation between items. And I'm going to start with an example based on the S&P 500. So if I'm using this one is because we are using this example since now more than 12 years, and it's a very nice network. So I'm going to start with a kind of reminder of our usual utilization of this data set, or of this example more precisely. So our usual example is to use 6 years of historical data of the S&P 500 data set. So we have 6 years of data that contains the daily stock returns, right? So this means that we have a data set made of 1,510 rows. And here it's not exactly 500 companies, but 459, if I remember correctly. And so we have this information here that is described. And so each row here is the variation of the stock price with respect to the day before, right? And each column is a company. So the idea is just here to find the relationship between this company based on the relationship between the variation of the stock price, right? So if we have a look at the distribution of these stock prices, so for the first one, advanced micro devices, we can see that over the 6 years, we have a normal distribution, more or less, where the mean is equal to 0, right? And we see that the max is minus 0.3 and the mean, more precisely, minus 0.3 and the max is 0.2, right? So we are going to here discretize these values by using the R-squared GenOp, which is the best algorithm here for representing this normal distribution, right? So we are discretizing these 459 dimensions, and then we have a network with 459 nodes, right? And if I switch to inference and if we have a look at the distribution, we can see the result of this R-squared GenOp. So here, this is a distribution that capture really, that is a discrete representation of the continuous distribution of the density function here, or the distribution function. So now we are going to see what are the relationship between these nodes. And for that, to be really efficient, we are going to use the maximum weight spanning tree. So which is an algorithm that's just the idea is to build a tree. So we are not going to have any V structure in this network, if you will. And then we just focus on the strongest correlation between these companies. And again, it's purely correlation. There is absolutely no causality here, right? So we have this network. Just a little bit of formatting. And now, as usual, I'm going to search Procter & Gamble. So here it is. It's blinking. So I'm going to zoom in this area just to see what is the neighborhood of P&G here. And we can see that we are finding the competitors of P&G. Kimberly-Clark, Johnson & Johnson, Kellogg's, and so on. And if I just, highlight or associate monitors with these nodes, I can simulate what if I'm focusing on the day during these 6 years where P&G increased by almost 3%, right? So I can say that during these days, well, Kimberly-Clark increased by 0.14 on average, 1.1 for Johnson & Johnson, and so on and so forth. But if we have a decrease of minus 0.3, same thing. And then if we have a look at the network, we can see here nodes that are related to the pharmaceutical area. We have here Packard that is at the center of the network. Then we have on the left here chemical companies, and so on and so forth. So this is our usual example. Now, I'm going to use the same domain, but without any data at the beginning, at least. So I'm opening a data source, which is going to be quite simple. Just, I just have 3 rows in my data set. The first one is the name of the company, and then I have 0 and 1, just to allow BayesiaLab to consider these variables as really random variables, right? So I need at least 2 different values, right? So obviously, this data is useless, right? But it's just to allow BayesiaLab to create the nodes, right? So I'm going to have 459 nodes. So I just load this. And so I have just, again, the names. Now, so if I open the monitors, you can see that we have only 2 states. And now I'm going to select all nodes and create or use OpenAI to create what we call embeddings, right? So I'm going to generate embeddings. So an embedding it's a numerical vector that will capture the semantic of the variables. I'm going to describe a little bit what is an embedding in a few seconds. So I'm generating a data set here. And now, so let's talk about this. So an embedding, it's a very fascinating thing. So this allows to, so instead of having an ID for a word, for example, which would be kind of a stupid approach, here the idea is to describe a word. So here it's not really a word, it's more like a token. So words are divided into tokens, right? So a token, it's just a set of characters, if you will. And so on the left here, you have the list of all the tokens that are in the model, in the language model, if you will, right? So let's suppose that perhaps we have 30,000 different tokens here. Then here, this is an example of a shallow neural network. So we have here one hidden layer, and in our case, we have 1,536 nodes here, or neurons, more precise, in this hidden layer. And the idea of this network is to try, well, at least if I'm focusing on the word-to-vector approach with the skipgram, the idea is to you have one token activated, so all the other one are equal to 0, and there is just one that is equal to 1. So we are focusing on one token, and we want to predict what are the tokens, the neighbors, if you will. So among the millions and millions of documents that have been digested, if I see, for example, the token car, C-A-R, what are the other tokens that are on the left and on the right of this token? So for example, I'm going to have road, accident, I don't know, vehicle, and so on and so forth, right? And then this neural network is trained to predict what are going to be the neighbors, right? And this is super clever because then you are going to have another token, like, for example, motorcycle. And this will have probably lots of tokens in common with car, right? You're going to find also, accident, you're going to find roads and so on and so forth. So at the end of the day, car and motorcycles are going to be close, right? So the idea of the embedding is to just keep here the weights that are associated with the connection between the token and the hidden layer, right? So since I have 1,536 neurons here, I have 1,536 weights. So one token, instead of being just described by one indices, if you want, it's going to be described by a vector of 1,536 dimension. And car and motorcycle and perhaps plane are going to be not that far, right? Because they are probably linked to some neurons that represent, the concept of vehicles, right? And so we can really assume that these neurons are what we would call in a Bayesian network latent variables. So they are representing a hidden concept, right? So this is how we are representing a token. And we're going to see that it's not just token, but then we can use that for representing words and sentences, right? So this is really the very first piece of the transformer. So we have then access to the API to generate these embeddings. And now, so in my data set here, you can see at the lower right corner, I have now a data set, and it's not just now 0 and 1, it's a vector. For each of my companies here, I have a vector of 1,536 dimension, right? So I have to discretize this vector, right? So I'm not going to use here R squared job because I don't really care about the distribution here, but I'm going to use quintiles, right? So equal frequency to 5 bins. And then, so here, if I double click, I can see that my nodes have been discretized with quintiles, right? And the values here, well, we don't really understand them. This is just something that is more or less centered around 0 and more negative than positive. And well, this is the weight associated with the neurons, right? So, but we don't know what are these neurons. But we know that if we are close, if the concept is close to the other one, then we are going to have a vector that is close to the other one. So we are going to now go to learning maximum weight spanning tree and identify the strongest correlation between these companies. So we have now this network. So just a little bit of formatting. Again, I'm going to search for Proctor. And so first thing on the left, you see I have this big cluster of nodes where I can see that it seems that they are associated because we have corp. So they all have corp in their name, more or less. But well, so this is one drawback, obviously, of this approach. Here we see Procter is associated with PPG. I don't see the link either, but also with Colgate, Clorox, Johnson & Johnson. So we have some similarities, right? So just again, you have to remember that all these associations are just based on the name. So among all the documents that have been digested, when we found PNG, what was the tokens that were close to PNG in these documents. So now, just to try to get rid of this problem here, I've created another data set where I have kind of clean the name of the company. So instead of having Coach Incorporation or Coach Inc., I remove the Inc. part, right? And same thing for the Corp and so on and so forth. So I have a data set with short names, if you will. So advanced micro devices, still called advanced micro devices. So same thing, I'm loading this data set just with 2 rows, generating the embeddings. Then discretization, quintiles, and then maximum weight spanning tree. Okay, layout. And now search again Procter. And first you see there is no, it seems we got rid of the corp cluster here, right? So this is where Procter is, and we have the connection with Johnson & Johnson, Colgate. We still have PPG, so perhaps it's because of the P and G, I don't know. We have a connection with PepsiCo and so on, right? So it's better, but probably not perfect, but quite interesting to see how this network is created with almost 500 dimensions and without any data set, right? Or except, obviously, the data set made of the embeddings, right? If we continue to explore a little bit this network, So with the Intel, Microsoft on the right here with Oracle and so on. Then we have, the semiconductor, our friends from Micron here, associated with microchip technologies, the chemical companies. So I would not say it's a perfect network, but it's still very interesting, right? So now let's suppose that I'm going to use this network for creating clusters, right? So this is our classical workflow when we do PSEM, probabilistic structural equation models. So I just want to use this network to group the nodes together. I go to learning, clustering, variable clustering, and I have 100 clusters. And as usual, so here the idea is to define, so the class, we create one class per factor. So the first factor is called factor_0 and contains Packard and Diamond and fraud reading, right? Then we have factor 1, General Mills, Gannett, and so on and so forth, right? And here we had another idea in order to leverage the power of ChatGPT is to say, well, because here we call that factor 0, 1, 2, 3, 4. So this is because it allows us to automatically then doing multiple clustering. And if you are familiar with our multiple clustering approach, you remember that the nodes that will be created, the latent variables that will be created for summarizing these groups of nodes, usually take the name of the strongest node, right? So for example, perhaps this cluster, once I have created the hidden variable, will be named air product on chemicals, because this would be the strongest node within this cluster, right? So just because we are, I'm not going to say lazy, but this is a very efficient way to have a name without losing information, right? So because the best approach, obviously, is to analyze the cluster and then define a name that is useful, right, for the analysis. So here, the idea is to say, okay, so now that we have a subject matter assistant, we can also use it for perhaps find a useful name, right? So I'm selecting all my factors here and click on this new button, generate description, right? So I can define here the context of the analysis or not, and then generate a prompt for having a description of my 100 factors, right? So this is sent to ChatGPT. We have to wait a little bit, and then we have the answer. So as you can see, I have a name associated with each of my cluster now. So the second one, for example, established American companies, well, not very useful, but still here, for example, factor 3, we have consumer good and services company where we have P&G. So again, I'm not saying that this is something perfect. So we still have this, well, obviously the same problem as with ChatGPT, but this is a very, very nice assistant, right? So we have now something that describes the clusters, right? And now I'm going to continue with my second example about the authors. So the idea here is to try to find relationship between authors, right? So very quickly, because I see that it's already 10 to 3. So here I've just selected, 65 authors that I've recently read. And then I have my list of authors, so same process, right? So just a name and 0 and 1. So I have my 65 here. And then, so I'm opening my data set. And I'm going to use the exact same process. So I'm selecting my nodes, go to embedding generation, then, so I'm creating these vectors of 1,536 dimensions, quintiles, maximum spanning tree, and then some layout to have a view, right? So now I have a network that represents a relationship between my authors here, right? So we see André Malraux connected with André Gide, connected with André Breton. So perhaps it's because of André, but it's also, André, it's also reflecting, the 21st century. So perhaps it's also because of that, right? So then we have Montaigne connected with Descartes, with Spinoza, with Harari. So it makes sense, right? Caddick with Philip Roth, and so on and so forth, right? So here it's just, again, same thing as the example with the S&P 500, just based on the name of the author. So now the idea is to try to have a better analysis, right? And here, I'm going to use here the comment generator. So it's another feature of the SMA where I'm going to ask question, and instead of creating nodes, I'm going to add the answer to the comment that is associated with the node, right? So here I'm going to ask, for example, for the main year. Here, one answer about year, and I'm describing the context, so literature, philosophy, and science, right? I'm generating the embeddings. And so I can see Yulia Pearl, the most important here, 2011, when he receives the ACM Turing Awards, right? Perfect. Then we have all these years that describe, that are associated with the authors, right? And then, so here this is an approach that we can compare to our usual probabilistic total equation model, because now what I'm going to do is create embeddings, but that are going to use not just the name, but the name plus the comment. So it's more or less the same thing as creating another node or creating a cluster based on the name of the author plus the comments, right? So it's really like creating a kind of latent variable. So I'm creating the embedding for that. And then usual workflow, discretization, maximum weight spanning tree, layout. And we have a new network here. And now it makes more sense. Well, at least it takes into account the year, right? So we see here at the bottom, the connection between the philosopher here from the 17th and 18th century. Then we have Albert Camus, 1942, connected with Stephen Zweig, 92, this one 84, Paul Auster, 85, and so on and so forth. So now the relationship are based on the name plus the year. And I can continue. I can say, okay, now I want to add the main characteristic of this author. So I'm generating that, and I'm going to append this dimension to the actual comment, right? So now I have, you see, for example, Philip Roth, provocative writer. This is and I can see that there are some mistakes sometimes. So for example, you see Mathurin here, Charles-Robert Mathurin, that has two input instead of one, and the second one is just a mistake, right? Instead of having only one. So I can just get rid of it. So I uncheck this one. And then I have another one with Daniel Kahneman here, where I have Nobel Prize winner in economics. Instead of being in the description, it's in the name. So I'm just removing that, right? And then same thing, generate the report here. So I can see the report. So George Orwell, 1949, political awareness, right? So I have all these comments now associated with my nodes, and I'm going to create the embeddings, then quintiles, then maximum weight spanning tree. So probably in the near future, we are going to have a workflow that do that automatically. Right, so here, the relationship are between the name, the year, and the main characterism. So absurdism for Camus, and so on and so forth. So now I can add another one. Let's suppose that I want to have to incorporate the three most important influencers for each of these authors, right? So this will really allow me to have connection between these authors that takes into account now year, name, characteristic, and influencers. And then I have another network. So the final one, which is again like a PSEM, where I'm clustering the name, the year, the characteristic, and the three influencers together to create a new variable. So you see the connection between here, these guys. So Edgar Allan Poe has influenced Ray Bradbury, Huxley had influenced by Wells, and so on and so forth. Okay. So last thing, I can use DALL-E for creating icons that I can associate with these guys. And then I have a representation of my authors here. Right? And so I want to conclude with the last example about Bayesian network. So here it's going to be a shortest one. The idea is instead of loading a data set, I'm creating a node, Bayesian network. So the field of the main dimension of my domain here. And then I'm using my SMA for generating here. I'm selecting 20 types of requests, right? And I want 5 answers per dimension here. So I'm going to have 100 answers coming from ChatGPT. So I have these 100, as you can see. So I have the threads, the dimensions. So most of them, or some of them are kind of synonymous, right? But not exactly the same one. And then so I have a set of 100 nodes along with their sticky nodes here, right? So now I'm excluding Bayesian networks, hiding the sticky nodes. And since my nodes are, some of the requests are very close, I'm gonna delete the nodes that appear several times, right? So just by selecting those that have a bracket in their names, then I'm using the layout function, and I'm gonna learn with the usual workflow, embedding quintiles, maximum weight spanning trees, the relationship between these dimensions. And here we have a representation of the Bayesian network domain where I did not have any data set. I just create a node, Bayesian networks, and then I have 100 nodes that describe, or here now just perhaps 70, that describes the domain. And you see there is a part for the structure, a part for causality, a part for prior knowledge, a part for learning, and so on and so forth. So it's quite fascinating. And we can conclude with node force analysis here. So the size of the bubble is proportional to the strength of the node, if you will. So the sum of the correlation associated with the node in this case. And so the most important one is conditional priority. So perhaps because we have more than one node about conditional priorities, but not only. And so you have the representation of this domain. So these were the 4 examples I wanted to show you today. I can see that I'm a little bit late. But if you have any questions.
Well, first of all, thank you, Lionel. This was a most fascinating and inspiring presentation. I'm truly in awe how these technologies are coming together, and I have a feeling that there will be so many applications. In fact, during your talk, I've already thought about how this could be applied to a couple of real-world use cases. So, but instead of me talking further about this, I see we have a number of comments and questions. Okay, let me see who has raised their hand. Oh, yes. Let me...
So I can see the question about the anchoring bias.
No, actually, the first question we have from Yong Zhang. Yong, welcome. Good to see you again.
Yeah, can you hear me now?
Yes, we can hear you.
Yeah, thanks. This is really amazing presentation. And apparently there are going to be a lot of, like Stephen commented, there's going to be, we need to think through how to use this This is amazing. And in PNG, we are also exploring large language model, not just GPT model, but also other model. But I never thought you guys already way front of us to incorporate these things into software. So maybe the first, couple of two questions really. So the first one is this in the latest release already? And the second, of course, is if you use, I know you probably use the API key inside the BayesiaLab to call GPT. Is that an additional fee? Is BayesiaLab paying that, or the client will pay for that? Thank you.
Yeah. So thank you, Young, and welcome to this conference again. Too bad we cannot meet in person. And for the first one, I was waiting for this question, and unfortunately, we are struggling with the new Java version. We are struggling with security for the installation packages and so on. So the release of this new version is going to be in, I know that Denis is listening, so I'm not going to say it tomorrow, but more something like 2 or 3 months. So even though we are really trying to make it quicker, but yes, so I think to be reasonable, it's going to be in 2 or 3 months, but perhaps, I don't know if we are going to be able to release some kind of beta version, and I will keep you posted anyway. And so for the second answer, yes, indeed, in BayesiaLab, you have in the settings, you're going to have a field for entering your API keys. So this is every user have to provide its own API keys, right? So we have another feature, for example, for translating the nodes, the commands, the state, and so on in any language. So same thing here. You can use either your OpenAI key, or if you are using DeepL, you can also provide your DeepL key. So you have these two options. And I'm saying 3 months for the new release, but in the meantime, I think we're gonna have to think about integrating Bard when they're gonna release it. And then we have also our strategic partner, Causality Links, with whom we are working a lot for automatically creating networks that are causal. And when I show them these features, they say, "Oh, wow, this is wonderful." So we are gonna also probably integrate Causality Links in the coming months, or at least I hope, right? So, and since there are lots of different options, perhaps we're going to have a list of subject matter assistants at the end of the day.
Okay, yeah, that's great. So one follow-up is the CPT table you generated using the embedding, they are not really, how to say, interpretable. You can't really do any drivers, any simulation anymore, right?
No, it's just, when you are focusing on the 20% of the neurons that have a low level of activation, or the connection between the token and the neuron is let's say equal or between -0.5 and -0.3, then you have X% of the other nodes that have another distribution. So we just know that they are correlated, but indeed it's meaningless. Right?
Okay, thank you so much. Look forward to the new release.
Yes, you're welcome.
All right. Let's see what other questions we have.
So we have
Hussein asked about the anchoring bias. I think that related to the very first part of your question. If you could address that, please, Lionel.
Yeah, Hussein, hello. So this is one of my friends with whom we are doing lots of brainstorming session. So I'm not surprised about this question. And so no worries with the anchoring bias, because the idea is to use this tool once we have already asked the question to the experts, right? So we don't start with that. We just start with the usual Delphi approach for eliciting the dimensions. And then it's really like we have an additional expert, then this will allow the expert to find additional dimension. If you remember what we did a few weeks ago, if they are not rejecting this assistant, because you know how it is, they're just, this is not working, it's just hallucinating and so on and so forth. But as we can see, we did it, we tried it during one of the session a few weeks ago, and the dimensions that were generated by ChatGPT were very, very interesting in the context of our elicitation model. So no problem with anchoring. Unless you start with that, but this is not what I would do.
All right, let's see. Whether we have any further questions. I see some popping up in the chat, but considering that we're now running slightly behind schedule, I suggest that we defer answering those new questions to answering them offline, or perhaps later in the session if we have time left. In any case, I think this kind of justifies what you said, what you presented. This really justifies that we need conferences more frequently, because I think there will be such rapid innovation that we really want to disseminate these new technologies and share that with our community.